So level 6.2 is, unfortunately or fortunately for some of you guys, all about the unit circle. So the unit circle is a circle with a unit measurement of 1. So for all of these, r is 1. And even before we start this, I want you to remember back to geometry. We always talked about two special right triangles. So one, we have a 45, 45, 90 degree triangle. So a 45, 45, 90 triangle says you have side, side, and then the hypotenuse would be side times the square root of 2. We can prove this with the Pythagorean theorem if we wanted to, but I'm not going to waste your time to do that. The second kind of right triangle we have is a 30, 60, 90 triangle. So we're going to call this angle up here 30. We're going to call this angle 60, and that's our 90. So the side always opposite 30 is the side length. The side always opposite 60 degrees is side times the square root of 3. And the side opposite the right angle is 2 times the side. This is review. So when we have our trig functions, if you remember SOHCAHTOA, this is where they come from. SOHCAHTOA. If you've seen that before, sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. Tangent of an angle is opposite over adjacent. So what we're doing is we're looking at a circle, and we're taking an angle, and we're putting that, in standard position. So we're taking an angle here, and we're saying this angle right here is going to be just a right triangle. And this is our r, this is our x value, this is our y value. So from this triangle, sine of an angle is just y over r. In our case, we're saying that the radius is 1, so it just turns out to be the y value. Cosine equally is x over r, tangent is y over x, and then these three functions, which you should be familiar with, but in case you don't know, this is cosecant, which means it's the inverse of sine, the reciprocal of sine. Secant, SEC, is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Okay, from all of this, we are going to build the unit circle. So the unit circle is a circle with a radius of 1. So we can do, what we're going to do is systematically go through this. Starting here, if our radius is 1, then our x value is 1 and our y value is 0. If we go up a quarter, our x value is now 0, our y value is 1. If I go to the left, I'm at negative 1, 0. And if I go down, I'm at 0, negative 1. If we're talking about our angle measures, so we're going to fill out all of these outside. This is 0 degrees. And if I go all the way around the circle, it's 360 degrees. So we'll get to that in just a second. If I go, first we're going to do count by 30s, because one of our special triangles is a 30, 60, 90. So we're just going to count by 30s. So we go 0, 30, then we go up, we go to 60, then we go up and we go to 90, then we go 120, then we go down here, we have 150, then we have 180. Second portion, add another 30, we get 210, add another 30, we get 240, add another 30, we get 270, add another 30, we get 300, add another 30, we get 330, add another 30, we get 360 degrees. So just walking around the circle by 30 degrees, we get all of these outside angles. What are the measurements? Well, as we said here, for a 30-degree angle, what's the cosine? Or The cosine, in our case, is just the x value. The sine value is just the y value. So if we drew in a triangle here, the cosine value is going to be, I'm going to draw this triangle for us. We have 30, so this is 1. This is, sorry, our radius is 1. So this means that this side is half that length, which is 1/2. That means this side, if we did a little algebra, is √3/2. So this measurement right here, this x value, is the square root of 3/2. And the y value is 1/2. If we did it reversed, we have a triangle. If we're up at this angle, this is 60. So then this is flipped. This is 1. That means that this side is √3/2, and this side is 1/2. So the x value here is switched. Now it's 1/2. This side is √3/2. If you only know this first quadrant, you get all of these other quadrants for free. What do I mean by that? Well, we add one more acronym that you might have seen. All students take calculus. What this acronym does, this means that the x and y values are positive. This means the sine values are positive. So that means that the x is negative, the y is positive. Here, only tangent is positive. So that means that the x and y are both negative. And here the cosine is positive. That means the x is positive, the y is negative. Okay, so if we walk around the unit circle here, so instead of 1/2 comma √3/2, now the x's will be negative, so negative 1/2 comma, the y is positive, √3/2. At 150, it's just the negative version of this, so negative √3/2 comma 1/2. We got 180. So in the third quadrant, x and y are both negative, so I'm going to do a different color. We have just the opposite down here, negative √3/2, negative 1/2. Here we at negative 1/2, negative √3/2. And finally, in the fourth quadrant, the x's are positive, the y's are negative. So this would be 1/2, negative √3/2. And this angle right here would be √3/2, comma, negative 1/2. So these are all of our multiples of 30 and their coordinates along the unit circle. So the only part we're missing are these quarter marks. So we're going to cut 180 degrees into quarters. So even easier, cut 90 degrees in half. We get 45. If you can count by 45s, you're good. So 45, then we got 90. Add 45, we get 135. Add another 45, we get 180. Add another 45, we get 225. Add another 45, we get 270. Add another 45, we get 315. Add another 45, we get 360. So now we are walked all the way around. We just need our xy coordinates. So I'm going to draw our right triangle that we should know. Here's our theta, and this is going to be 45 degrees. So we know that if the radius is 1, then the two sides of the right triangle, if you just trust me, are both √2/2. So 45-degree angles are super easy because they are just the same. √2/2, comma, √2/2. Here, the x's are negative, so negative √2/2, √2/2. Here, we're at, both are negative, negative √2/2, negative √2/2. And then here, the x's are positive, so √2/2, negative √2/2. And this is the unit circle. The only thing that we're missing is, well, if we can take everything in degrees, we can also measure it in radians. So that's what the flip side's for. We're going to do, I'm just going to write out the radians portion of this circle, and all of the coordinates will be the same. Okay, so like I said, here's the same blank unit circle, and on the inside portion, we're going to write all of our radian degrees. So starting with 0, same thing. Start with 0, and if we go all the way around a circle one time in radians, that's 2 pi. So if I take half of 2 pi, I'll end up here, which is just pi. If I take half of pi, I get pi over 2. If I take if I go between pi and 2 pi, I get 3 pi over 2. So this gets me my angles. And just so we remember, this is 1, 0, 0, 1, negative 1, 0, 0, negative 1. Okay? Next up, I'm going to cut everything into quarter pieces. So half of pi over 2, or half of a half, is a quarter. So pi over 4. Now I'm just going to go pi over 4. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. That gives me my radian measures all around the circle. Likewise, I'm going to divide everything into sixths. So we're going to count by pi over sixths. So I'm going to use a different color here, and we're going to start with pi over 6. If I add another pi over 6, I get 2 pi over 6, which is the same thing as pi over 3. If I add another pi over 6, I get 3 pi over 6, which is 1/2. If I add another pi over 6, I get 4 pi over 6, which is 2 pi over 3. If I add another pi over 6, I get 5 pi over 6. If I add another pi over 6, I get 6 pi over 6. If I add another pi over 6, I get 7 pi over 6. If I add another pi over 6, I get 8 pi over 6, or 4 pi over 3. If I add another pi over 6, I get 3 pi over 2. If I add another pi over 6, I get 10 pi over 6, or 5 pi over 3. If I add another pi over 6, I get 11 pi over 6. This is walking around the unit circle in radians. First we did halves, then we did quarters, then we did sixths. And just as a refresher, pi over 6, we're at root 3 over 2, comma 1/2. At pi over 4, we're at root 2 over 2, comma root 2 over 2. And at pi over 3, we're at 1/2, comma root 3 over 2. Likewise, you could fill in the unit circle, which I would expect you guys to do, with all students take calculus, which means we have both positives, we have negative positive, we have negative negative, and we have positive negative. So we will be having a quiz on this in class at some point, where you will fill in a blank unit circle with both degrees, the radians, and all of the ordered pairs. So if you want to think about the way I think about it, first divide everything in half pieces, then we can count everything in quarter pieces, and then we can count everything in sixth pieces. And in class, I will show you guys a nice little hand trick to remember both the coordinates with the angle measurements. So now that we know a little bit more about the unit circle, and we've had a little bit of practice with it, I want you guys to now be able to, if I give you a x value, you can tell me what the angle is. Or if I tell you, if I give you the angle, tell me what the coordinate is. Now remember, working with the unit circle and the unit circle only, we have cosine of theta equals x and sine theta equals y, which means in the ordered pairs, cosine is the x value and sine is the y value. So first off, given the xy coordinate on the unit circle, find the exact values of the 6 trig functions. So our 6 trig functions, we have sine, cosine, tangent. Then we have cosecant, secant, and cotangent. So this is what we're going to be finding for each one of these. So if we have our unit circle, and I say, where is root 3 over 2, comma 1/2? So if we look at this unit circle here, we see that we are at theta equals pi over 6, or 30 degrees. Either way, this is just for our unit circle. So if we want to know what is sine of theta, all we're asking for is the y value. So that is 1/2. The cosine of theta is equal to the x value, or root 3 over 2. The tangent of theta is equal to the y over the x, or 1/2 divided by root 3 over 2, which is the same thing as 1/2 times 2 over root 3, which is 1 over the square root of 3, or root 3 over 3. Now once we get all of that, if we do the reciprocal functions, I'm going to do this in a different color, cosecant is just 2 over 1, reciprocal of sine. Secant is just 2 over root 3, or 2 root 3 over 3. And cotangent is, well, 1 over this, so just root 3. And these would be your 6 trig functions for the given function. I'm going to do this for b. So b, I have 2 root 2 over 3, comma negative 1/3. This is not on the unit circle necessarily, but I can still find sine of theta is equal to negative 1/3, because that's my y value. Cosine of theta is 2 root 2 over 3, because that's the x value. And tangent of theta is negative 1/3 divided by 2 root 2 over 3, which is the same thing as negative 1/3 times 3 over 2 root 2. So then this is just negative 1 over 2 root 2. Rationalize that, we get root 2 over 4, so negative root 2 over 4. For, in a different color, for cosecant, it's just negative 3. For secant is the reciprocal of cosine. For us, we can just write that as 3 over 2 root 2. If we wanted to, that would be 3 root 2 over 4. And then cotangent is simply 2 root 2, because it's the reciprocal here. So this is what we mean by, if I give you a coordinate, you write out the 6 trig functions. So for example 2, find the exact value without a calculator. So if you notice, none of these angles are on the unit circle. So the goal is put angles onto unit circle by adding or subtracting 2 pi. Because if we add or subtract 2 pi, it's like unwinding a circle or adding a circle onto something that spun backwards. And all we're trying to do is find out what's the equivalent angle on the unit circle so we can figure out where this is, what's the coordinate. So 11 pi over 2. So 11 pi over 2 is more than 2 pi. So if I subtract 2 pi, which is 4 pi over 2, I get 7 pi over 2. That's still bigger than 2 pi, so I'm going to subtract another 2 pi, which is 3 pi over 2. So sine of 11 pi over 2 is the same thing as saying sine of 3 pi over 2. Now, if we go to our unit circle, we see that that's in the bottom of the unit circle, so that is the y value, and the y value is negative 1. So how about an easier one? if we have the sine of negative 3 pi, we're going to add 2 pi to it. We get negative pi. If we add another 2 pi to that, we get pi. So I want to know the sine of negative 3 pi, which is the same thing as the sine of pi. So if we know what the sine of pi is, which is 0, then we know what the sine of negative 3 pi is, because we're just spinning around in a circle. So the answer is just 0. Tangent of 6 pi is the same thing as tangent of, subtract 2 pi, we get 4 pi, subtract 2 pi, we get 2 pi. Well, the tangent is y over x, or sine over cosine. And if we look at the unit circle, it's 1 comma 0. So this is 0 over 1, or 0. Last up, the cosine of negative 3 pi over 2. So negative 3 pi over 2, add 2 pi, which is 4 pi over 2. So that's the equivalent of pi over 2. So cosine of negative 3 pi over 2 is the same thing as the cosine of pi over 2. And the cosine of pi over 2 is 0. Last up, example 3. Find the exact value without a calculator. Okay, so without a calculator, sine of 45 degrees. We go to sine of 45 on the unit circle. We see that is square root of 2 over 2 plus the cosine of 60 degrees. So we go to cosine of 60, and we see that cosine of 60 is 1/2. So here we have root 2 over 2 plus 1/2, so that is 1 plus root 2 over 2. And that is our exact value. Likewise, we can do B. Tangent of 45 is root 2 over 2 divided by root 2 over 2 times cosine of 30 is root 3 over 2. Well, this is just 1. So then multiplying this, we just get root 3 over 2. Last up, sine of pi over 4, root 2 over 2, plus cosine of pi over 4, root 2 over 2, which we have 2 root 2's. This is 2 root 2 over 2, which is just square root of 2. Hopefully these explanations made sense. If I went too fast, please let me know. Problems are below, and good luck.